Hello everyone, I'm Safreen. I'm currently in second semester of my master's in business analytics and information system, and today's demonstration is aligned with my ongoing course that is big data for business. So this is our current module which is dedicated for Cassandra programming, and this demonstration is for our assignment where we have to demonstrate DataStax Astra Cloud Cassandra database connection with Python programming. So this demonstration will include where we have to create a database in DataStax Astra Cloud. And then we have to connect to that database. Then we have to query using Python programming and to play with some queries and applying filters with partition key and non-partition key. So first of all, we have to let's go to the astra.datastax.com. So here in DataStax Astra Cloud, we will create a database. So for that, we have to create the account first, and then we will land on this page where we can see the databases. So here we will create the database. So in the right side, you can see the create database option. If you click on that, we have to select a deployment type. I have selected the serverless non-vector database. Here we will give the database name, then the key space name, so it's like a namespace where we will have our tables created, and this is the provider. So Google Cloud is the one which I have used, and the region, we can select the region from here. So for this demo I already created one database called Cassandra DB. So let's go to the database. So this is the database. We can see that it is in active status, and here the key spaces which I have created. So we will mainly work on this key space, that is big data. If we go into the tab connect, here if we go down for Python programming connection steps, we'll see some prerequisites. So for that we will need a secure connect bundle which we'll use to obtain the connection credentials to our database. So from here, we have to download the bundle, and then we will need one application token, which we will download from here, generate token. So for this, I have already downloaded this and I have kept it in my working folder. So this is the Cassandra DB token file, that is the JSON file, and this is the zip folder for Secure Connect Cassandra DB. So if we just have a look on this JSON file, we can see like the client ID is given, secret is given, the token is given. This is the application token. So this will be used while establishing a connection for the database. So let's let's move on to the Python programming part. So the first step is we will need the Cassandra driver package to be installed. So I have did the pip install Cassandra driver. This is the command. Let's execute. This is in progress. Yeah. So actually I already have all the drivers installed in my machine, so that's why it is showing this requirement already satisfied. So the next step will be setting up environment variables. So there will be two environment variables will be required. One is Astra DB secure bundle path. So this path will be the path of the zip file which I shown earlier, and the second variable is Astra DB application token. So this is the path for that JSON file where we have seen the client ID secret and the application token. So these two variables we will set it up. So let's run it. And yeah, this is done. Now next is we will try to establish a connection with the database which we created in Astra Cloud. So let's go through some code block here. So here we will have some necessary packages imported. Here for cloud configuration, we will need those two environment variables which we have set in the earlier steps. So here it will, in the cloud configuration, this file will read, and the next step is the application token, where we will here the client ID and the secret will be fetched here. And the next step is here I have used a plain text authorization provider, where we will pass the client ID and client secret. This is for the authentication purpose, but in the production environment, it is not advisable to use plain text authorization provider. So for that, we have to use some identity based or for secure connection. So the next step will be um, to connect to the Cassandra cluster, we will need this configuration. We need to pass this cloud config and the auth provider to the cluster, and the cluster dot connect. It this line of code will help to establish a session, and the big data is the key space in which we will work mainly. So let's execute this cell. So yeah. So we have successfully created the connection with the Cassandra cluster. We have established a session, and we are into the key space big data. So here I have defined a key space because this is going to be used in the next part, where we will create the tables and we'll play with the queries. So I executed this, and the next step is we'll create the table. So this is my create table query. I'm creating a stream table. Here there are some fields like stream tag, the ID. So I have kept it as video ID, the added date, which will be a timestamp, title of type text. And this table will have the primary key, which is the combination of tag, added date, and video ID. So this will uniquely identify the records in the stream table. And so the tag will be the partition key, and the added date and the video ID will be the clustering columns. And we are specifying the clustering order here. So for clustering order, we are using added date, and it is descending, and video ID will be the ascending. And here we are providing the key space which we have initially defined, that is the big data. And let's execute this query. So yeah, so we can see that we are able to create the table in the Cassandra in the Astra Cloud. And now let's just verify uh, by going into the SQL console. So whether we are in we can see at least a table which we have created. So right now there is no data in the table. So before doing anything, we have to just first you go into our key space. So for that, our key space is big data. So use big data. So now we are into our key space. Now I'll just see select star from stream. So yes, we can see the empty table, and the table is created successfully. So let's move on to the next step where we will add some sample data inside the table. So this is the data, and this is the insert query. So all this sample data we will insert here, and I've provided for loop where we will insert all these records one by one. So let's run this. I think we have successfully inserted the data. So the next step is select query execution, where we will verify whether the data got inserted into the table. But before executing this query, let's just verify in SQL console first. So yeah, we can see the data is successfully inserted, and even we will verify here in the Python through the Python program. So this is the select query, select star from key space dot string and session dot execute, and here we will pass this query, select query, and just for making sure whether the data is there, so I'm just printing the data here in the console. So we can see all the records here in the notebook. So the next step is applying the filters. So here, this is the query where this is the query select star from key space dot stream where clause in where clause we have two fields like tag and the title, and I have given the allow filtering. So this is required when we are filtering or applying filter to the table with the non-partition key. So if for example if I remove this and if I execute this, so here tag to query, I'm setting the filters. So I wanted the videos which have tag signs, and the title to query will be quantum mechanics explained. And here in the session dot execute, I've passed the filters and the query. So let's execute this. So yeah, as expected, we can see here the error, that is cannot execute this query as it might involve data filtering and thus may have unpredictable performance. So whenever we are filtering our table with non-partition key, it impacts the performance of the query, performance of the database. So it is not advisable in production. We should use the non-partition key filtration in production. And if still we want to just see how we can apply the filters using this non-partition key, we need to use allow filtering keywords here in the select query. So I have put the allow filtering here. Let's execute this. And now we can see the filtered result where we have the tag science, video ID, and the title. So yeah, so we have seen filtering, and let's see the last query, that we able to drop the column through drop the table from the Python program. So this is the drop query, drop table if exist key space dot string, and will execute this query. So let's execute it, and the table has been dropped. And let's just verify here in the SQL console. So I'll just try to just hit the select chart from stream and see we can see that the big data.stream table does not exist. So we can say that we are able to successfully even we can successfully drop the table to the Python program. So I'm done with my demonstration. Thank you everyone.